In this video, we will talk about polynomial functions and their graphs. We will identify what polynomial functions are and recognize characteristics of graphs of polynomial functions. We will determine end behavior, and I'll tell you what end behavior means. We will use factoring to find zeros of polynomial function, identify zeros and their multiplicities. I will explain multiplicities. We will use intermediate value theorem, understand the relationship between degree and turning points, and then we will graph polynomial functions. So what is polynomial function? So the definition for polynomial function is let n be a non-negative integer. Like for example, the function f of x equal a(n) x to the power n plus a(n minus 1) x to the power n minus 1 plus so on, and a(2x squared plus a(1x plus a(0). Now this is kind of polynomial function. N is non-negative integer, and these are all real numbers, like a2, a1, a0, these are all real numbers, and an is not supposed to be equal 0. An is a coefficient in the front, so this is called polynomial function of degree n. The number, this an, like I said, is a coefficient of the variable to the highest power. It's called a leading coefficient. So this is my leading coefficient. This is my leading coefficient, and this is not supposed to be 0. Now, always polynomial function is supposed to be in order, like the highest degree is supposed to be in the front. Like if I have a 2x 8 to the power 8 plus a or maybe 1x to the power 7, so it goes in order. The highest degree is supposed to be in the front, so that's the order of polynomial function. Now polynomial function if the degree is 2 or higher, it means when the n, this is a degree, is higher or equal to 2, then the graph supposed to be smooth and continuous. Now what is smooth means? By smooth we mean that graph contains only rounded curves with no sharp corners. So it contains like rounded curves like this, like these are rounded curves, no sharp turns, like no sharp corners or turns, like something like this. This is a sharp corner. So we don't have that. We shouldn't be having that. So we call the curve smooth. What is continuous means? We mean that graphs have no breaks and can be drawn without lifting your pencil from the coordinate system. You see, I started here, there are no breaks, there are no holes, it's just continuously going. What is end behavior? Now end behavior, I'm going to use a different color. End behavior means the graph of the function to the far left or far right is called end behavior. So this is far, you see, this is end behavior, this is far left, and this is end behavior, and this is far right. So these are the end behavior. The graph of polynomial function may have intervals where it increases or decreases. The graph will eventually rise or fall without bound as it moves far to the left or far to the right. The sign of this leading coefficient, like an, that one, and the degree n of the polynomial function will tell us how the end behavior goes, and I'll give you all of that stuff. Okay, so Let's do the leading coefficient test. I'm going to write here leading coefficient test. And you guys know the leading coefficient that I have is an, this, right? This an is a leading coefficient. So I'm going to show you how, when you see the leading coefficient, you will see how the graph works. So if my leading coefficient is, this is my leading coefficient, is greater than 0, which means it's a positive, then the graph falls to the left and rises to the right. So the graph falls to the left and rises to the right. Just remember, memorize this. If the leading coefficient is greater than 0, this is left side, that's the right side. This is left falls and the right rise. And I will show you how the graph would look like for this. For example, that's my coordinate plane. I'm just making it up. It's gonna go, that's my left, fall left, right? And this right, rise. So this is falls left. This one rise, right. Okay, so, and another thing you guys should remember here for this, odd degree positive leading coefficient. There. When you have an odd degree, like the n is odd, then you can have a positive leading coefficient. Then the graph look like this, falls to the left, rise to the right. Now let's do another one. We have, for example, leading coefficient is less than 0. If the leading coefficient is less than 0 and my degree is still odd, okay, I didn't write that here, I can write here odd. Okay, so this is the information you guys memorize. Okay, in this one, please memorize that. If that's the case, okay, let me remove that. I have to show you. So if this is the case less than 0, then which means the leading coefficient is negative, the graph rises to the left and falls to the right, falls to the right. So you guys should memorize that. And how the graph look like for this. For example, it says rises to the left. So I'm rising to the left. Okay, I'm rising to the left. And it's supposed to go down. Go up like this, and then it falls. There. So it rises to the left and falls to the right. So this is fall right, and that one is rise right, left. There. And again, odd degree, it means odd degree and negative leading coefficient. In this case, odd degree okay, so I have odd degree, negative leading coefficient. Okay, we have 2 more to go. If my what is it? if the n is even and the leading coefficient is greater than 0 and n is equal, like it's even, the degree, the power, the exponent, this is what I mean by n, it's even, then it's gonna rise to the left and it's gonna rise to the right. So you guys memorize this portion and I'm gonna show you a graph. The graph look like this. It's rising to the left and it's also rising to the right. So both of them are rises. And this, the degree is even in positive leading coefficient. Okay. Let me move this graph. Okay. There is one more. If my leading coefficient is okay, why it doesn't work? I move them. Okay, good. Now leading coefficient is less than 0 and the degree is even. Then it means the leading coefficient is negative and the graph falls to the left and falls to the right. This one is kind of easy, the even degree ones, because if it's greater, both rises. If it's less or negative leading coefficient, then it both falls. So the graph for this one look like this. It falls there. It also falls to the left and falls to the right. And it's even degree and negative leading coefficient. Okay. Now we have example now, and I'm going to use this example, this one. I'm just going to move it here so we can work with it. Okay. Now in this case, we're going to use the leading coefficient test to determine the end behavior of the graph. In the graph, the function for this graph is f of x equal x to the power 4 minus 4x squared. Now the degree of the function is 4. So I'm going to write down everything here. The degree of the function n is 4 and it's even, right? 4 is even. Even degree function have graphs with the same behavior at each end, right? If it's positive, then both are rising. So in this case, since the leading coefficient is 1, so an is equal 1, because right there invisible 1, and it's positive, so the graph rises to the left and to the right. And you guys can see the graph is right here rises and right here also rises. So this is how, if it's even, you guys should know if the leading coefficient is positive, then it means both rises, and if it's negative, then both falls. Now, 0 of polynomials. Let's talk about 0 of polynomials. If f is a polynomial function, the value of x for which f of x is equal to 0 are called zeros of f. Like if I make f of x equal 0, and they call zeros. The x values are always called zeros. So we also call this root or solutions of the polynomial function. real root of the polynomial equation appears as an x-intercept of the graph of the polynomial function. So 0 means zeros of f function means the x values, like x-intercept. You can also call this, I'm just showing you different vocabulary words. You can also call them roots or solutions. So these are all for the x values, like x-intercept. So I'm going to give you example for one of this. The example is, they said find all the zeros for f of x equal x cubed plus 2x squared minus 4x minus 8. So this is my function and I'm looking for zeros. We find the zeros of f by setting this equation equal 0. So, and we will solve and we will factor out, and we will figure it out how to work with this. And always remember, guys, if you have 4 terms, you can always make it as a group. So you can make a group solution for it. For example, I'll take these 2 and I'll take these 2 as a group. So for this one, x squared is my common factor. So it's going to say x plus 2 minus, in this case 4 is my common factor, so x is going to stay inside and this one is going to go positive 2, because negative times negative, negative times positive will give me negative. So this is what my x plus 2, x plus 2 are exactly the same. So we can say it's going to give me x squared minus 4. We pick these 2 and then we have a x plus 2, just one of them, and then all of them are, we already know they are equal zeros. Now how we find 0 in this case? You're going to make this factor equal 0 and you're going to make this factor equal 0, because zeros means to find the x values, like x-intercepts. So this is going to give me x squared equal 4. You add 4 both sides. This one subtract 2 both sides because they're jumping over the equal sign. This is going to go square root. So x is equal positive negative 2. And this one is going to be x equal negative 2. So these are all my zeros. Now, if you guys pay attention up here, this is the graph for the same function that we were working on. So this is the graph. I wanted to move it back, but I think it's not gonna move. Okay, fine. So what I can do here, that if you guys see, positive, negative, and negative 2. So I have a positive 2 right there. I have negative 2, and they are like an x-intercepts. So these are my zeros. So if you guys look at it, the graph of shows each 0 is an x-intercept. The graph passes through 0, this and this negative 2, right? And this is also going, it's not crossing it, but it's right there. Okay, what is multiplicity means and how multiplicity can help us figure it out what's going on with the graph. So we found the zeros, and you guys can tell the zeros is called x-intercept, where the y is always 0. So it's going to go 2, 0 and negative 2, 0. Since negative 2 are 2 of them, so I'm just going to pick one. Like, you don't have to pick twice. Okay, so these are my zeros, and these are also, you can call them like x-intercepts. X-intercepts means when y is always 0. Okay, so this is what we talked about, what is 0 means, and we can call them solutions, roots, zeros. These are all the x values. These are different vocabulary words like zeros of f, x-intercept, roots, or solution. They are all means x value. Okay, let's talk about multiplicity. multiplicity. Now multiplicity, we have a specific form of multiplicity that you guys should remember always. It's like this. This is exponent k, this is r like a 0, like x minus, like we did up here, right here. X plus 2, x squared minus 4, that's exactly this form. And k is the exponent. R is acting like a 0, like an x value. So I'm going to say if r is a 0 of even multiplicity, if r is a 0 of even multiplicity. Even multiplicity means I'm talking about even exponent. Even multiplicity. Then the graph touches, then the graph touches the x-axis and turns around at r. Okay, then the graph, if r is, that's one. Second point, if r is a 0 of odd multiplicity, like k, or odd multiplicity means, I'm going to write again, even multiplicity I meant k, odd multiplicity I mean k. Okay, what is the exponent? Then the graph crosses, then the graph crosses the x-axis. At r. Okay, so let's do example for this multiplicity so we can understand it better. Okay, here's the example. I have a function f of x equal negative 4 x plus half squared and then x minus 5 to the power 3. We're gonna figure it out, the multiplicity of the zeros, and then we'll figure it out if the graph crosses the x-axis or touches the x-axis and turns around at each 0. So we're gonna find the zeros first. We're gonna set this equal 0, this whole function, and we're gonna figure it out how to work with it. Now I'm gonna make this, I know this is negative 4, so you divide negative 4 both sides, you're gonna get 0, this negative 4 disappears. So I'm left with x plus half whole squared equals 0. So to get rid of this exponent, we square root it, right? We square root this, we square root this 0, both sides. So I'm gonna get, okay, I'm gonna show you, I'm gonna get x plus half equal 0, square root of 0 is 0, and they cancel out. And I got x equal negative half. So this negative half is my 1, 0. Let's figure it out for this one. X minus 5 to the power 3 equals 0. If this is cube, then to get rid of the cube, I'm multiplying this by 1/3, reciprocal, right? And both sides. So they cancel out. I'm left with x minus 5 equal 0. Then x equal 5. So my another 0 is 5. Guys, remember this. Since that was square, then square root would work for it. If it's a cube, then you can do the cubic root, but a cubic root also means 1/3 anyway. Like if I can rewrite this x minus 5 like this, that's a cubic root. And if I write this x minus 5 1/3, same thing. They are exactly the same thing, okay? The same thing goes here. If the square root, this means half, so I can write x plus half squared and times 1/2. This 1/2 means the square root anyway, so they cancel out. That's how it goes. So my zeros are a half and 5. Now if you guys pay attention, we're gonna find the multiplicity of the 0. What is the multiplicity of the 0? This is a multiplicity of 2. Multiplicity means what? exponent, and this is even multiplicity, right? Multiplicity of 0. So you can say the negative half is a 0 of multiplicity 2. This one is a 0 of multiplicity, and you can tell that's a 3 cube, that's odd. Okay, like odd, or I'm sorry, I should have write 3. Now we can tell that in this case, I'm going to draw a graph and tell you what's going on with the graph, okay? And if you closely pay attention up here, if the multiplicity is even, right? This is even 2. Then it means it's going to touch the x-axis and turns around. So this one, I can say it's even. K is equal even. This K is even. Then it touches and turn around. That one is K is odd. Then it's gonna cross x-axis. Okay, let me write down my numbers. I have, for example, 1, 2, 3, 4, 5, 6, 7, and 8. Right, and up here I have -1, -2, -3, -4. I can say up here is 200, this one is 400, that one is 600, and so on. Down there, -200, -400, and -600. There you go. Now let's figure it out. At a negative half, this is my negative half. I'm going to use a different color, probably bright color something. Okay, this is negative half right there, right? And then I have x equal 5, which is right there. These are my x-intercepts, these are my zeros, these are my solutions, whatever, roots, whatever you call them. So these are my, these zeros. Now the negative half is even, so it's going to touch and turn around. So the graph for this function, that's how it looks. It's going to touch and turn around. Okay, up here at 5, it crosses. So at 5, it's going to cross the x-axis. Okay, so actually the graph of this look like something like that. Something like this. So you guys can tell what I mean by all the multiplicity. Okay, now let's do intermediate value theorem. Intermediate value theorem, we can write this like IVT, intermediate value theorem. Intermediate value theorem. All right. Intermediate theorem means if f of a and f of b, if f of a and f of b have opposite signs, then there is at least one value, then there is at least one value of C between A and B, for which f of c equal 0. So let's do the example. They said show that polynomial function f of x equal 3x cubed minus 10x plus 9 has a real zero between, has real zeros between -3 and -2. So this is what they're asking me. When this is the case, then it's intermediate value theorem. So what we're going to do, we have to figure it out. What is the y value? F of -3, and what is f of -2? Once we figure it out, if one is positive, one is negative, like they have opposite signs, then it means there is at least one c between a and b. So let's try. I'm going to plug in -3 first. 3 -3 cube minus 10 -3 plus 9, and this is going to give me -81 plus 30 plus 9, which will end up -42. When I plug in -2, it's going to give me cube minus 10 -2 plus 9, -24 plus 20 plus 9 equal 5. So another one is 5. Okay, so that's how we got -42 and 5, which means there is a c between a and b, and there must be f of c between f of a and f of b. Now you can tell up here, this is the graph of the same function. So we can tell up here in this that 3x cubed minus 10x plus 9 f of -3 equal -42. Do you see the graph up here? And f of -2 is equal 5. The sign change shows that polynomial function has a real zero between -3 and -2. Real zero. Zero means what? What am I talking about here? This zero means I'm talking about x values, right? We have zeros. We can call this roots. We can call this solutions. I just want to repeat my vocabulary words with you guys. So this is how the graph look like. And you can tell the graph is crossing the x-axis. When you have one negative, one positive, you know the graph is crossing x-axis. And like you're going from positive to negative, negative to positive, like it crosses the x-axis. So there is this is what's called a intermediate value theorem. Okay, let's do the turning points of a polynomial function. Turning points of a polynomial function. Okay, if the turning points, you can figure it out how many times the polynomial function is turning. All you have to do is to know the degree, and you subtract the highest degree, subtract 1 is going to give me turning points, like how many times it's turning. Let's do the example for this and we'll figure it out. The example that I have is 2x plus 2 squared and x minus 3. Okay, the first thing first, I would suggest to FOIL this out and multiply with x minus 3. Then you know it's going to give me x squared, and this is x1, and you multiply x squared and x1 is going to give me x cubed. So the leading coefficient technically is x cubed, right? So let's figure it out how the graph end behavior is going. The leading coefficient, an is the leading coefficient, which is 2 and it's positive, and my degree is 3, which is odd. So this is odd and this is positive. I'm just going to write positive there. So if you guys remember, if your coefficient, if your degree is odd, then it means it's gonna fall left and rise right, and you can go up there and check in the video in the beginning. I told you guys to memorize this. So this is what's happening. If you have the degree is odd and the leading coefficient 2 is positive, then the graph will rise on the right and will fall on the left. So for example, I have this -1, -2, -3, -4, -5 up here, 1, 2, 3, 4, and 5. And these are my y-axis, and I have -1, -2, -3, -4, 1, 2, 3, 4, positive. Okay, so since I said this is supposed to look like that, so I'm gonna make it, it's gonna go like this, and it's gonna go up here. This is how it's supposed to look like in the first step. Now next we will figure it out our x-intercepts. And how do we find x-intercepts? Or you can call them, how do we find zeros, or how do we find roots? So you're gonna go and find x-intercepts, which means make this whole function f of x equal 2x plus 2 whole squared x minus 3, and make this equal 0. Then divide 2 both sides, it disappeared. Then I have x plus 2 whole squared equals 0, and I have x minus 3 equals 0. To get the x-intercepts or zeros, use square root because I need to get rid of this square, and the opposite is going to be square root. So I got x plus 2 equals 0. Subtract 2 both sides, it's x equal -2. There is my x-intercept, and this one add 3 both sides, it's going to give me x equal 3. That's another x-intercept. So I have -2 and I have +3. So -2 and +3. There you go. So you guys can tell, let's figure it out, the multiplicity for the, after we find the x-intercepts. Since the x minus 3, the multiplicity for this, like k for that one, is equal, it's 1. 1 means it's odd. For this one, k is equal, since it's 2, then it's even. Okay, so let's figure it out, how the even and odd goes. Multiplicity of 2, the graph, if it's even, it touches the x-axis. And then at x equal -2, it's going to touch, but it flattens and turns around. So this is how it's going to go, okay? This graph is going to go touch and then turn around. Next, at 3, +3, it's going to cross the x-axis. So +3, it's going to cross the x-axis. And it's like, it's going to cross the x-axis. There you go. Now, next, let's find the y-intercepts. I mean, we're going to find the y-intercepts, like we need some extra points to plot them and see how the graph is going to go. So I'm going to plot the points. And I have a y-intercept means when x is 0. So 2x plus 2 whole squared, x minus 3, plug in 0 for x. It's going to give me 2 and 4. And this is -3, and that's -24. Then I have -24, 0, -24 is my x-intercept, a y-intercept. So I'm gonna, I drew the graph up here, but let's make it, since our y-intercept is -24, then we need a -24 y. So this is -10, let's make it bigger, and -20, -30, -40. and up here on the top you have the same ones, 10, 20, 30, and 40. And I got 1, 2, 3, 4, and 5. This one is -1, -2, -3, -4, -5. So the graph was like we did at -2. At -2, it's since the multiplicity is even and it's positive and even, then it means it's at -2 it's gonna touch and turn around. So this is -2, it's gonna touch and turn around. Okay, and the y-intercept was 24, right? The y-intercept was 24, so probably 24 is right there somewhere. So this graph is gonna go over here somewhere. At 3 it crosses, so it crosses at 3. It's not really on scale, but I'm just showing you how it works. Okay, now it says since we already found the y-intercept, now we are going to figure it out how to do the turning points, how many times it turns. So since the degree is 3 and -1, so the degree is 3 minus 1, which is 2. So 2 times turning points we have. So 1 turning point, and this is my 2. Since this one was like actually going like this is not a turning point, but 1 turning point, and that's my second turning point. So we are okay since this is not on scale and we graphed it without using a calculator. So this is how it's supposed to be right here. Like, it's not a really beautiful graph, but you guys understand what I meant by turning points. You have 2. You understand how we get the multiplicity and stuff, like it crosses, it doesn't cross x-axis. And please make sure that you memorize all of this, and it's gonna help you big time, like odd, even, and even. So these are important. If you guys have any questions, please comment below. Subscribe, like, and share. Thank you.